Yeah. Hey, thanks everyone for having me. I can maybe at the end, if there's questions, I can pop on and can see my face, but I'll just jump into it. Today, really what we're going to talk about is just sort of like hot spots. It sounds like somebody might need to mute themselves, but anyway, hot spots that you'll see, whether it's new construction or existing construction out there, that just things to look for, and then what the product should look like if it's installed correctly. This is something we also do for builders too as well. So it's a good easy information presentation. And feel free to send some questions in the chat. Kevin Friday joined me too as well, so he might be able to answer some questions in the chat. Otherwise, we'll try to get to him at the end. So the building code does require installation instructions on the job site, and this is our installation instructions. This is our catalog. We have a variety of catalogs. This one is for wood construction connectors. We also have ones for concrete anchors and fasteners too as well. So that's where you'll find a lot of our installation instructions. Also, the website has our installation instructions as well. So luckily, most people do have smartphones or iPads or something like that, so they should be able to get that installation instruction pretty easily, just by searching the model number of the product that's installed. Couple general notes. So these are general notes in our catalog, some for specifiers, some for installers. And these are just a few that I just wanted to point out because they tend to be the hot ones that come up a lot. The biggest one that we see, and hopefully you guys are not seeing, is unless otherwise noted, bending steel in the field may cause fractures in the bend line. Fractured steel will not carry the load and must be replaced. So there should be a picture as we get along, but if you see products that have been modified, that those products need to be replaced or evaluated by a structural engineer. Also, bolt holes shall be at least a minimum of 1/32 inch and or no more than a maximum of 1/16 larger than the bolt diameter. So if you see something that's over drilled, that's going to be a concern too as well. And that's also per the NDS. So if you see that, even if it's for something else, that's a concern, whether it's a connector or not. For joist hangers, Simpson Strong Tie recommends the hanger height shall be at least 60% of the joist height for stability against the rotation while under construction prior to sheathing install. So that's just talking about how the size of the joist hangers when it comes to height. And that's actually a building code requirement now. It used to be 50%, but now it is 60%. So just to jump into it, and I hopefully this is a nice and easy presentation to follow. But one of the biggest things is when we start off, looking at construction, the mudsill or foundation plate for new construction, a lot of builders like to use L bolts or J bolts, as they commonly call them. These are cast in place bolts. One of the biggest problem with these cast in place bolts is that they are not always in the correct location. So in this case, just notching out is not going to work. So location really is key on these bolts. If you look at the building code, you need to have one bolt within 3.5 inches from the end of the plate up to 12 inches. So there needs to be one at each end of the plate, and then every 6 foot on center when it comes to prescriptive spacing for residential construction. So how can we fix that? There are concrete screws like our Titan HD that have been evaluated for this type of application, and it's a great way to fix an application like that. So easy fix. Again, hopefully you're not seeing bolts in the wrong place, but that's definitely something that happens when it comes to cast in place anchor bolts. Some builders like straps. If you're seeing straps, biggest thing you want to check would be, do they have a current code report? The one on the left and I'm not going to name any names, but the one on the left does not have a current code report. So no builder should be using that one if they want to meet the building codes in most jurisdictions of the United States. Also, the straps, when they are installed in concrete, need to be spread properly to wrap around the size of the mudsill plate that you're using. So in this case, you can see on the left-hand side, they didn't spread the straps properly to wrap around the the plate. So if they do install it, like, if they do install a code-approved strap, they would need to drill the plate just like you would an anchor bolt, and then wrap it around the opposite versus. So real quick, hopefully you're not seeing what is pictured on the left, but if you do, that is a bit of a concern when it comes to mudsill straps. Another concern with mudsill straps are, when you run into framing like studs, pictured on the left-hand side, not very many straps, or even this strap that's pictured, are evaluated for this application. So this is a concern, and a retrofit or repair would need to be done in this situation, because those straps are not evaluated for to go up a stud. The MASA strap by Simpson Strong Tie is evaluated to run a leg up a strap. So if you did see an MASA strap going up a stud, as long as it's installed properly, that is okay. Double mudsills. This tends to be pretty common for some builders trying to get additional height in the foundation or in the basement of a house. The strap on the left is not evaluated for this application. That is an MAB 15 manufactured by Simpson, and we do not have any testing to support a double mudsill application. So a repair would need to be done on the left-hand side, or the builder could consider the MASA. It is tested for a double mudsill application. So those are some options. Again, for a Titan HD screw anchor would be a great repair for the picture on the left-hand side. Embedment depth is really important, not only for anchor bolts, but also for straps. So if you look at the strap picture on the left, the MASA was embedded a little too far, and it is not properly fastened to that mudsill. So that part that you can see on the left-hand side needs to be on top of the mudsill. If you look on the right, you can see that the strap has been properly embedded, and there are 3 fasteners going into the side of the plate. So that would be a correct installation. The one on the left is not. So embedment really is key for these, and if you run into something like on the left, then a repair would be required. A lot of times builders will use wedge anchors, which is a common name for basically an anchor or an expansion anchor. And they will install these, to fix a situation where maybe an anchor bolt was misinstalled or a strap was misinstalled. And that's a good fix. The biggest issue is edge distance. A lot of times with wedge anchors, depending on the diameter, you may need to have 3 inches of edge distance for a 1/2 inch wedge anchor to get capacity. And if you don't have the proper edge distance, you could have the concrete cracking or spalling, like what has happened in this picture on the left-hand side. So wedge anchors work in some applications, but not all. The edge distance is very critical. An alternative would be to use that Titan HD screw anchor. Those can get much closer to the edge. The reason why is they cut the concrete. They don't put any expansion on the concrete. So it's less chance of any cracking of the concrete versus a wedge anchor. And then edge distance is also critical when it comes to straps, especially these large STHD 14 straps. These are very common in markets that are addressing wall bracing. Wall bracing very often is a solution for builders is to use a portal frame with hold downs. These STHD 14 straps work very well for those portal frames. However, you need to have concrete that wraps around the embedded part of the strap. So if they're not properly installed with the correct edge distance, in this case, you need 1/2 inch minimum end distance too as well. You can get situations where the concrete's going to break off and spall. And then embedment for these large straps do matter too as well. So if you embed them too far, now the fasteners are not getting properly installed into the studs. And when that happens, you don't get the full capacity of those straps, which is very often needed, especially if you're maybe on the West Coast and you're using these straps for a shear wall application. That load is very critical. So missing 4 fasteners might change the load quite a bit. So installing properly with the depth is very important. And this would be something that needs to be addressed by a structural engineer to decide whether or not this works or if there's a fix that's required. Talked about this in the general notes, the over drilling of, obviously, if you over drill, then you can have very loose connections like the HD2A on the left-hand side. So properly drilling the correct size hole reduces that chance of loose connections, and we don't want to see loose connections. Carriage bolts. Hopefully you're not seeing a carriage bolt in a hold down like the one pictured on the left-hand side. Our hold downs require machine bolts. That means you should be seeing a hex head bolt on the opposite side with a washer. The other thing that's not required is the hold down does not require washers. So only the wood part where the bolt. The other side, if you look at that hold down there, the HD2A, there's some washers on the nuts, and that's not required. The washers would only need to be on the hex head side with the wood. So that's another way to maybe save a builder some money. Just let them know, hey, you don't need those extra washers there. It's not going to change anything, but it's just not necessary. This one happens, unfortunately, sometimes where you may see a misinstallation with our HDU hold downs. The picture on the left is an HDU5, and unfortunately, the seat, which is like a crescent washer, so it looks like a half moon, that actually needs to fill that curve of that HDU hold down, and that's to get the proper load capacity for the HDU. If it's installed like it is in the picture on the left, that is a misinstallation and a repair would need to be done. Also, the other big concern with that HDU is it is a little bit spread too wide. So that gap in between the 2 flanges is a little too much there. So hopefully we're not seeing that, that would need to be addressed. So the picture on the right does show a properly installed crescent washer, as well as the spreading of the HDU hold down flanges. When it comes to anchoring a lot of these hold downs, cleaning the hole is very important. There's instructions when you're using adhesives, whether that's a cold weather adhesive like an acrylic one, or if you're using an epoxy, which, just real quick note, most epoxies cannot be used for less than 40 degrees. So, and these 2 videos will hopefully show what it looks like if you do not clean your holes properly.
Dirty hole.
Um,
Let's see what we get.
So as you can see from those two videos, it's very important to properly clean the holes when it comes to adhesive anchors.
So, Michael, just for clarification, that was in a laboratory.
Yeah, that was done in a laboratory, correct?
And then the one on this, the second one, the bolt broke before it withdrew.
Correct. So if you properly clean a hole and use and follow the instructions for adhesives, most likely the rod will fail before the adhesive fails.
That makes the point. Those videos make the point.
Yeah. Another one I hope you don't see out in the field is again, we talked about this first in that general notes, modifying a hanger or joist hanger or strap or something like that. As you can see right here, they took a hanger and they just bent the flange back and nailed it. Biggest concern is the metal could fracture and fail. The second concern is the fasteners are now going in the end grain of that 2x10 or 2x12. I'm not sure exactly what size. And the National Design Standards for Wood has prohibited nails in the end grain since the 1944 edition. So we won't get any load capacity of nails in the end grain. A concealed hanger would work great for that application. So, and here's another picture of a modified post cap. Again, if you start to modify the post cap and bend the steel, it's very possible that you're going to get a failure. And there's, unfortunately, the manufacturer is not going to stand by and give you any load capacity for that connector anymore. In this case, if you're using a built-up beam on top of let's say a 6x6 post, there are post caps that are designed for that application that can handle 3 2x10s on top of a 6x6 post, or a double on top of a 4x4 post. And then there's also post caps that work in tandem together that could be used as well. Here's another application where the strap was modified. These twist straps often come out in the way they're manufactured in a very straight and what happens when you bend them in this application right here, you're just not going to get the load capacity. So they can be bent at the tail ends to wrap around like a top plate or a truss as pictured on the right hand side. But when you bend it right at the angle where the twist strap is, the load, it's not going to work in tension like it's supposed to. So hopefully not seeing that either as well. When it comes to I-joist hangers, the biggest thing is not to overspread the flanges. When you see an overspread flange, like the picture on the left, that is going to essentially raise that floor joist and create a bump in the floor. And then it's also just not going to be able to support it as well for rotation. So we don't want to see situations where the I-joist joist hanger flanges are spread. If you look at the picture on the right, the flanges are tight up against the top flange of that I-joist, and that's what we want to see. Another thing to keep in mind, a lot of I-joist or a lot of suppliers do supply the Simpson strong tie ITS or IUS hanger. These hangers have a snap-in seat or a strong grip seat, and this allows no fastening in the I-joist. So yes, the nails will go into the top flange of the carrying member or into the side of the carrying member. However, the I-joist or the joist does not require any nails. And it's a little hard to see here, but someone put some nails in that strong grip. As soon as they do that, they have now possibly cracked, or, you know, the bottom flange of that eye joist, which will most likely create a squeak. And most builders do not want a squeak, but also, you know, we don't know what the capacity of that eye joist is anymore either if you start splitting up the flange.
So, Michael, somebody just asked a question similar to what I've been thinking, and you brought it up a few minutes ago when you showed where that joist hanger had been altered. Um, but it's come up. It's like you're showing us the wrong way, and you're showing us the right way. The question is, well, what do we do? What kind of what needs to be done when it's done the wrong way? What are the solutions to these? You might want to give some thought to that as we're going through the presentation. If
I
you're
mean,
making
in most
comments on that.
in most cases, basically an engineer needs to evaluate the situation and decide, you know, is it okay or not, or it needs to be replaced. But it would need to be evaluated in most cases by a structural engineer to see whether or not it's an issue.
That sounds to me like the answer we would get from a factory rep. But we live in the real world out here,
Mhm.
and we can't bring in an engineer every time a joist hanger is improperly installed.
Yeah, and I understand, but all I can tell you is what a factory rep is supposed to tell you. I can't tell you whether or not something's going to work or not. If it's not installed per our installation instructions, then that we basically have no load to provide you, and no, all we can tell you is it's not installed properly.
I think what Hollis is asking, a good example might be, okay, if you have a truss and the flanges are spread, okay, that's not right. But it's got to be more than zero tolerance acceptability. How far, quarter inch, half inch, there's got to be some guideline where it's a concern worth being beyond nitpicking, or where it's serious.
Well, that's not the point I was making. I saw a question in the chat. My question is, and I'm a framer by trade. I understand that this is a dynamic that I've had to deal with my whole life, or at least a third of my adult life. And it is. I mean, so there's when joist hangers are improperly installed, especially those that are supposed to be nailed, be fastened before the joist is placed in them. And now you're having coming back after the fact. It's a challenge. And so I appreciate, Michael, your response where you're saying, my job is to be the factory rep because I'm the factory rep. So you're going to get the factory reps response from me. And so in the real world, the good news is that we don't have to come up with answers, but it's often it's kind of handy when we can. So yeah, we can carry on. We don't need to dwell on that conversation, that much farther. We did have another question. Something that we see frequently in the field is where they're putting construction adhesive in the joist hanger. I think they're trying to control squeaking. What's your take on that stuff?
That's probably gonna be another factory rep answer for you, but we really have no answer for you on that one. We're not gonna say it's bad, and we're not going to say it's good. We're just going to say we're not going to say when it comes to putting glue in the seat, it's very common, and our stance is basically we have no stance. So you can do it or you cannot do it. It's up to you guys as a builder.
So it's not required by your specification, and it's outside your scope if somebody does it.
Correct. Yeah.
I'm going to jump in on that too, Mike. With the IUS and the ITS, I'm typing this in there. We don't have nails into the bottom flange with those insets. So that's the main cause of squeak. So we don't, you don't necessarily need them in those type of hangers because there's no nails into the bottom. So that's the reason we designed it that way.
So you're saying you have squeak resistance built into the joist hanger, and therefore the glue shouldn't be necessary. Is that what you said?
The hanger was designed
Optional. It's optional.
Right. I mean, it's really optional. The hanger was designed with truss joist and their silent floor system. So the idea was to remove nails in the seat, because that was one of the the areas that they found created squeaks. So, you know, that was our way of doing it. If a builder wants to add an adhesive there to put some additional, you know, comfort in his construction, and maybe it's very possible it works. It's also very possible that you don't need it.
And in the real world, it's very likely that neither is going to solve the problem, and the damn floor's still going to squeak.
If they again, if they overspread the flanges, that could create a squeak. If they put a nail, what other builders I've seen do is they'll toe nail the eye joist first and then put the hanger on. That's probably going to create a squeak. So there's a lot of different ways you can create a squeak in a floor system. Yeah, so there's definitely a lot of ways to mitigate it, but it's unfortunate that there's other ways you can create a squeak.
Following the rules helps.
Yeah. So yes, this is another way you can create a squeak. If you don't use the proper size hanger, like if you in this case, the builder used a hanger that's a little bit too wide for the joist. In some cases, if you use a hanger that's wider than the joist, you can put some blocking in there to help fill that width. However, adding blocking is going to increase your chance of a squeak. So talking about squeaks, it's usually best to get the proper size hanger and then install the hanger properly too as well. Here's one where this hanger might work in this application, but again, what happens here is you have to put a filler block in there. The filler block will not only increase your cost for construction, but the filler block also increases your chance for squeaks. So highly recommended when it comes to engineered lumber that you're using a hanger that's designed for engineered lumber. Getting into trusses and the roof structure, one of the biggest problems is, and this is not necessarily a manufacturing issue, typically trusses are designed to meet the sizes that are required for this structure, but what happens is the building's framed, sometimes the walls and things move, and this creates gaps between the hanger, or between the truss and the girder truss that's holding that truss. These gaps need to be addressed by a hanger that can support that amount of gap. This THA hanger that's pictured in the left-hand side only allows up to an 1/8 inch gap for proper installation. I believe we may have some testing that allows a load up to 3/8 of a gap for that same hanger. But as you can see in the picture, it looks like it's almost a 1/2 inch. And in that case, a replacement would make sense to find a hanger that can handle a 1/2 inch gap.
So Larry points out that in that picture right there, that I realize that's outside your scope. You're focused on the hanger, but the lamination of that girder, some pretty big spaces in that girder.
Yeah, and I think if they laminated the girder properly, maybe that would have helped mitigate some of the gap issues too as well. You know, there's a lot of things that are possible. So,
Or it might actually have increased the gap if you closed it up. It might actually made it farther.
Right, it might have gone the other direction too.
Yeah. You can always tell when the framers are in the audience. They see things that the rest of us don't see, and I mean, that's true when we have electricians and we have an electrical presentation. So, please forgive us if we pick on you too much.
No, it's fine. I mean, these pictures, both Kevin and I have been with the company for so long that these are not necessarily recent pictures. We've been able to collect pictures throughout the year, and we've worked with builders to help with their framers when it comes to mitigating these issues in the field, and so that's where a lot of these pictures have come with, is to help train their framers and give them some support on like what to do and what not to do. So that picture back there, that might have came from 2006 for all I know. I'd have to go back and look at it. Hopefully we're not seeing it as often as maybe it sounds like when I'm talking.
Yeah, we see it every day.
Okay, well, then,
That's why you're here.
okay. Well, hopefully we can all, at least help educate the builders so that way, when they go to the next house, they're able to maybe not have that issue. Missing nails can reduce the capacity too as well. So, using a hanger, or in this case, a hurricane tie that's designed for a thermal heel truss will allow you to get the higher load capacity. So it's possible that they didn't need the full capacity of the H2.5A that's pictured on the left-hand side. But if the load capacity was necessary, then an H2.5T, which is a little bit shorter, would be an option to get a higher load capacity for a thermal heel truss. And just to point out, that picture on the left, that H2.5A, if the nails are left out, the top two nails, if you leave those nails out, we do actually have a load for that H2.5A with the 3 nails going into that. So, and that might be enough load. So those are things, ways you can help the builder too as well. Here's exactly that situation where the builder or the framer put some additional nails in that top of that H2.5A. And unfortunately, in this case, I do remember where this picture came from. The building inspector made them fix every single one. And another option might be to use a screw. We do have a new truss screw that you can use for this application, or that other H2.5T that's made for some of these thermal heel type trusses. And again, just going back to modifying connectors, we really don't want to see guys creating holes in our connectors, because at that point, again, we don't have any load capacity to support that connector anymore. So, finding an alternative, like using a like a hurricane tie or 2 TSP straps, twist straps, that might be another solution to help avoid, hangers being installed into hangers. And this picture on the left is really a little bit dramatic. This is really, I think if you do see this in the field, I would encourage you to just, talk to the builder and let them know, hey, you don't really need to put that many straps on. First off, angling them is not going to maybe not create a great load path at an angle. You're probably not going to get the proper amount of fasteners in there, but they're also spending a lot of additional money that's not necessary. So this is a situation where you might talk to the builder and say, hey, on your next project, why don't we, help you save some money and just, talk to the designer about putting the straps where they're needed, which may only be every 3 foot on center or 4 foot on center, to handle that load capacity. So more straps don't always make it better. And again, having the proper length strap is very important. So if you see in the picture on the right-hand side, that end length is very critical, because that's where the fasteners go. You don't need any fasteners in the clear span area. However, it is optional to put some nails there so they don't bow out. Then the clear span is going to be the more critical area, because you need to have the proper amount of fasteners.
So, Michael, I told you I was a framer back in the day, and we had a rule of thumb that we just always lived by, was if there's a hole in the joist hanger, there's supposed to be a nail in it. And I heard you a few minutes ago say that, well, we actually have a rating for just for not all the nails. Can you elaborate on that?
Yeah, so that's an old, a good one to when you have a new guy to teach them, to say, hey, if there's a hole, fill the hole. However, there's the caveat, and that is, if it's a strap, then that's not the rule. So, because you're not going to make it stronger by putting additional nails in a strap. The strap has only so much capacity. When we test it and evaluate it, we evaluate it with a certain amount of fasteners, and at that point, it probably is maxed out. So the general rule for connectors, yes, is fill every hole with the proper fastener. When it comes to straps, if you look in the installation instructions, it's going to say, hey, for maybe, and again, I'm not actually looking at one right now, but if you look at a strap, it might say you need 22 nails for this coil strap. You're going to divide that by 2. That means 11 nails will go in the top of the strap, and then 11 nails will go into the bottom of the strap. And that's right in the catalog, and that's your installation instructions. Or
Hey, Mike,
yeah,
just to add to that, when you say every hole, it's every round hole, not to be confused with diamond shaped holes or whatever.
yeah, and that's, yeah, definitely something to address as well. Our literature does show all the different holes in there, so you want to be conscious of which hole you're putting the fastener in, because sometimes there are hangers that have triangle holes, and that might mean that that's a max loading. So adding an additional fastener there might increase the load capacity of that joist hanger. So, and those are things that the designer is going to specify when they specify the joist hanger. So straps, and there's another hanger that does have a strap, but the THA hanger does have a strap built into it, and that we consider that a strap too as well. So that means you need to check the installation instructions to make sure that the THA hanger has the proper amount of fasteners first off, but then also doesn't have, the guys aren't putting too many in there. In some cases, you may only need 6 nails, so why put 30 nails in that strap?
So it seems like there's an awful lot of interest in this audience about the number of nails and holes without nails in them. I think about 3 slides back is when the conversation started, where I think you had a hurricane clip, and you made the where the 2 holes were above that bottom cord, and you commented that there was a rating for it with and without those 2 nails, and now here we are. Are we contradicting that, or?
Well, again, a hurricane tie, and so you're referring to this guy right here, basically this one, this H2.5A. Because this happened so many times, we tested this H2.5A hurricane tie with only 3 nails in the top. So that was a sort of a special situation, and the reason why, if there's no wood to nail into, then just don't put any nails in there, So, but it's not always common sense, right, guys? Like in this picture right here, you can see that they bent it over and then started driving nails into it. In that case, they've modified the hurricane clip, and now you unfortunately take all responsibility once you modify the connector. So, and so yes, reading the instructions is very important. And again, if a framer gets to a situation where it doesn't look like it's going to work, maybe pause and check either with the manufacturers or the installation instructions to see, hey, will I still get a load if I only put 3 nails in? And if he does, is that load sufficient for the design of the building?
We're still getting questions about nails, but why don't we move on? I think we're I think at the rate we're going here, we're gonna not move on to the next slide. So let's move on.
Yeah, I mean, yeah, nails, fasteners are the critical thing in our connectors, and the best thing to keep in mind is check with the installation instructions to make sure whether or not you're using the proper fastener or whether or not you're using the proper quantity of fasteners for that connector. Here's a situation where someone modified a twist strap and flattened it out using a coil strap like the one pictured on the right-hand side. Would be a good solution for that type of application rather than flattening out or modifying a twist strap. Hopefully you don't see this. This is a post base that's used in many cases for new construction. And that post base needs to be embedded into the the slab. So again, installation instructions, but if they're going to do something like this where they install the 4x4 afterwards, they can use a much less expensive post base. But this specific one needs to be embedded into the slab to get the capacity that it is published for. And then also, again, hanger selection is important. So if you have a low heel truss, you would want to make sure that you're using a connector that can handle the fastening for a low heel truss. This HTU hanger on the right-hand side is designed for that application, and IUS 2.5695 is designed for an I-joist and not designed for a truss application. So hopefully you're not seeing anything like that because it won't get the proper fastening. Here's another application where someone installed one of our new LSSR skewable slopable hangers right on top of a post cap. And clearly you're not going to be able to get the proper fastening there. So the builders, before they started framing, or the framers should have looked at that and said, hey, is there another option? Should we go to a top flange hanger or something that will work? So hopefully you guys can start slowing down, because we're just not going to get the load capacity if we try to install into a very thick steel. When it comes to plumbing, if it's a load bearing stud, they do require stud shoes. So, that's something to consider. If it's a non-load bearing stud, then you could use just a regular nail stop, but load bearing studs are going to require, in most cases, and this is a whole nother training can get into, a stud shoe to bring it back to full capacity. And then notching, there's only so much notching you can do too as well. And then a stud shoe would be required. And obviously it's a little bit harder to put it on there if you have a turn happening right at that, or an angle right at that stud. So maybe moving the stud would be an option. So you don't, but again, some changes in framing or using might help fix that situation. And again, when it comes to load bearing walls, especially exterior walls, that's where you're going to start to require either some heavy stud shoes, depending on whether that wall is resisting lateral loads or just down loads. Another situation where a stud shoe is going to be required, especially on a load bearing wall. And then reinforcing straps are also required for many applications, especially for load bearing walls to transfer the loads. So not just a plate to stop for nails, you also need to transfer the load laterally through the top plates. And one, unfortunately, that I still do see is, when it comes to HVAC guys, they like to make their own straps. These straps do not meet the building code. The building code requires a 16 gauge strap, not one that you just manufacture in the field. And you need the proper amount of nails, which is, I'm pretty sure, if I remember correctly, 8 nails on each side for these straps. So again, hopefully we're not seeing too much of this happening, but the proper straps to meet the building code are required. And I think that's it, but we do have literature that assists with installation, especially when it comes to the different types of nail holes. This is a pocket install guide, basically, that is free. We can send these to any builder, any installer, and it will assist with any questions related to proper holes, fastening, the amount of fasteners they need from many of the more popular connectors, and then go from there. So I think, do we still have enough time? Because I can get into the fasteners, or I wasn't sure how much more time you guys have.
Well, we have 15 minutes, but before we decide to do that, could you remind us about this is actually a certification class, that CertainTeed has a certificate that they're prepared to issue to attendees. Is that correct?
I mean, we can give you, if everybody signed up, I can give you a certificate that you went through basically a misinstallation training. You know,
So you sent me a link. So what I can do is I can forward that to everybody who is in attendance now, and if they fill that out, you will get that, and you will issue a certificate to them. Is that correct?
yeah.
Okay. All right. So anybody's yeah, so that's what I'll do. I'll forward that link to everybody who's in attendance tonight, and if you want that certificate, you click the link and fill out that form, and you'll get a cool little certificate from Simpson Strong Tie. Can we go back before we go forward, since we do have some time, since the absent nails seems to really be the what we got all the responses, and in fact I kind of pushed past it because I was afraid we were going to get hung up there and spend the rest of the night there, because we were looking at that that hurricane clip once again, that was where that conversation all started. And somebody was wondering, and so you were saying, okay, well, we did something specific because so often those top two nails hit above a 2x4. So rather than have people bend it over and drive nails through there, we gave a rating for it with those nails missing. But the 4 nails in the bottom section of that, they would still be required, right?
Yeah, I mean, they would still, you're talking about the 5 nails going into the top plate.
Yeah. Well, no, into the truss. Yeah, the nails going into the top plate of the wall. Yeah.
Yeah, still require, in that application, you would still need 3 nails going into the bottom plates or the top plates of the wall, or 5 nails, my bad. And then you would need 3 nails going into the truss. And that's tested, and we do have that evaluated. So, one thing, if you do see like a mixed installation, I always tell people before you do anything, call us and ask us, hey, have you tested this? Do you have anything to help me before you do anything? Unfortunately, if a builder or a framer tries to fix it themselves real fast, you might possibly make things worse. And so usually it's a good idea to call and say, hey, do you have have you tested this misinstallation? Do you have anything you can help us provide? And like for that H2.5A, we do have something. So I can say, hey, we've tested it with 3 nails. You're good. Just check with your designer to make sure that load capacity works. When it comes to other things, we may not have tested it, and we may not be able to provide any information, and they would still have to go to an engineer to have it evaluated. But I usually tell most people, try not to fix it first without checking with the manufacturer to see if there's any solutions, or checking with a structural engineer, because the last thing you want to do is make the problem more expensive.
So can you address the blind shear nailing? I think that's another one that we see frequently. And somebody's actually showing me the other day where they just reached in there with, somebody used like some 8-penny nails, and the inspector just reached up and pulled the nails out with his fingers. And I see you've actually have the picture right in the middle, in that middle graphic right there.
Yeah, and if you want, I can finish this last fastener section, and I believe it does address exactly what you're asking about. So what you're talking about is our double shear or slant nailing feature, and I do have a couple of slides on that. First off, proper size of hanger matters, and then not using deck screws. None of our connectors are evaluated with deck screws, so hopefully you're not seeing that installed with joist hangers. So
is that different from Simpson screws?
So yeah, I was going to talk about that, but we do have a structural screw that we did evaluate and manufacture specifically for our connectors. So I'll touch on that in a couple of slides. When it comes to our slant nail, which is that picture of that joist hanger on the left-hand side, that's an LUS 28 joist hanger. So that hanger has our slant feature, which is, you can see a top flange view of it right there, with someone has installed short nails into it, or 1.25 inch length nails. So that is a double shear application. So there's shearing happening where the fastener meets the hanger, and then there's a shear happening where the joist actually meets the header. So that's what that double shear means. But that requires a longer fastener there. So we need to get penetration into the header. If you use short nails, we just don't get the load capacity that the joist hanger has published. The reason why this was, or when this was actually invented, I believe in 1985, and the idea was to make it a lot easier to install the fasteners, right? They're at a 45-degree or 30-degree, I'd have to double check. But it's a lot easier to install that fastener at that angle than it is, coming around the side and hitting it. So for anybody who's installed these with the proper nails, it's very easy to install them versus the old school style hanger that you had to hammer in from the side. So that was the advantage. The other advantage of this hanger is it uses less fasteners. We can get a higher load capacity with a toenail than we could with the short nails just going into the side. But so in this case, as you can see in this picture, we need that long nail, a minimum 2.5 inch fastener going into the header to get that load capacity, and then to allow for us to use less fasteners. That was the whole idea. And it's also just a whole lot faster with that, again, with that toenail.
So back in the day, before this got as technical as it has become, we used to use roofing nails in joist hangers. And then they came up with those truss nails, the ones that they had actually a T stamped in the head of the nail that said these are the only the nails you can use in joist hangers. And now time has passed since that. Is there any indication? How do we know that these nails are long enough, or the right nails?
So it's not always that easy to know. Sometimes you can look underneath, and if there is like an 1/8 inch gap, you can look up in there with a maybe a flashlight or a camera, and you can kind of see if there is, a nail going all the way through into the header. It's very often easy to tell if you're looking at a truss hanger, maybe not as easy to tell when you're looking at a deck. So if there is concern, you might consider pulling one and then replacing it with one of our strong drive screws, strong drive connector screws. But unfortunately, you guys know, in the world of inspections, you can't always tell exactly if something's right or wrong. And there's maybe some trust element there with the builder, so all we can do is try to, educate them for the future projects in some cases. Like, hey, just let them know, hey, if you're using this hanger, make sure you're using 2.5 inch fasteners, and then preventing anything in the future from being misinstalled.
Yeah, one of our, we got a comment from the Peanut Gallery that says, rather than us telling the builders, perhaps somebody should be telling the manufacturers to put some kind of an identifying mark on nails that are approved for that application. The way they used to. I mean, they had that Tico put that T on those nails back in the day.
Yeah. Yeah, it's kind of hard because a builder often wants to use a cost-effective solution, and we do not necessarily always manufacture the least expensive nail, if that's the best political way to put that. So if a builder wanted a less expensive nail, now you have to go to the other nail manufacturers and tell them to all do, put the T on there. And that's where you might run into some issues. So what we do in our literature is require the proper diameter and the proper length of fastener. And then that gives the builder the option to use whatever brand nail they want to use in our connectors. So we're not limiting them on one option when it comes to a nail. And mostly because we're not necessarily in the nail business, if that's the best
No, that's fair enough. We got 5 minutes, so once you talk about the screws and the nail, go ahead, carry on. We got 5 minutes.
Yeah, so if the wrong fastener is installed, we do actually have a lot of information in our catalog that can give load reductions. And that's why I wanted to point out, like, please don't do anything right away. Let's evaluate the situation. Let's check the literature and see, are there load reduction charts? And then can we do the load reduction? Will that load still meet the application? If it does, now we can, maybe get an engineer to say, hey, everything's cool. Or the building designer might say, oh, yep, that load's good. Don't worry about it. Don't change anything. Don't overreact. So again, going through, those steps, this might, in this case, it might be an unsafe situation. In other cases, it might not be, by just doing some of the load reductions. So checking with our literature, or, if it is an issue where it's unsafe, we do have technical bulletin letters where say, you pull a couple of those nails, drive in some screws, and the screws get you back to full capacity. So there's a lot of solutions that we may have. And that's why I just say, like, try not to fix it right away, call us, and let's see if we can help you with solutions to repair or get it fixed. Pneumatic or metal connector nail tools, not that great. So make sure builders are using precision placement tools that have hole locating mechanisms, and they're using the proper length fastener. Here's one. Again, when we talked about straps are the exception to the rule. This THA hanger, in this case, only needed 6 nails going into the carrying member. And as pictured in this right here, unfortunately, the framer thought he had to fill every single hole. So now he added a ton of blocking to the floor system, which is only going to create squeaks. And he also, spent a lot of money on fasteners when he only really maybe needed to use 6 nails into the carrying member, and then another 6 nails going into the joist. So this is something where if you see it, I would, I would just encourage the builder to, read the instructions, and maybe don't do this in the future, so they can all save some money and save some problems in the future. Because this is probably not going to fail, but it's probably going to have squeaks for sure.
You got to give them points for good intentions on this one.
Yeah. And again, right here, the same thing with that strap hanger. It's not. It's fine. It's just a lot of cost going on right there by filling all those holes. It didn't increase the load capacity. So. But yeah, I mean, appreciate you guys' time today.